So if you go ahead and take a look at example number 2, can you go ahead and again draw the graph of f of x first? Can you make a graph of this? X squared plus 2. Okay, I think you still know how to make an x squared graph. What does the plus 2 mean in this case? What does the plus 2 mean in this case? Shifting. Shifting up 2 units. Okay, shifting up 2 units. So so therefore, the whole parabola will look something like this, and we will still use the 1, 3, and 5 to aid our graphing so that we can make a parabola very easily. And this trick, this little method of using 1, 3, 5, 7 to make a quadratic graph, it's going to be very, very beneficial. Okay, not just for this course, but for pre-calc, for SAT, ACT altogether, or even for calculus. All right, so everybody should be able to make a graph of x squared plus 2. Can you write down the domain and range in interval notation? When we ask for a domain, what are we asking here? The what value? The x value, right? So we're saying, hey, look at the graph. Does it cover all the x values? And we say, yeah. It covers all the x values, all the way from the left to all the way to the right. So it will be from -infinity to infinity. And by the way, whenever we are using the infinity in the interval, we always use parentheses because we don't really know what infinity really is. So we cannot include the end value of infinity since we don't know what it is. And for the range, what is the range? From where to where? From 2 to infinity. Now, I saw that people still have trouble using brackets and parentheses in interval notations. This is a bracket. We use a bracket in this case because the number 2 is included, okay, in this process. Okay. Now, just like what we did earlier, we convert the points, right? We just flip the x and y values of the point. So, so let's go ahead and do just that so that we can make our graph for the inverse. So we have a point, the vertex at 0, 2. That means our graph now is 2, 0. That's the new vertex. We have a point at 1, 3 from the left. So therefore, we shall have a point at 3, 1. We have a point right here at -1, 3. Then we shall have a point at 3, -1. We have a point here at 2, 6. That means we shall have a point at 6, 2. We have a point at -2, 6. That means we shall have a point at 6, -2. So if you can see the shape right here, you have a parabola going sideways. Okay. And if you look at this, can you list the domain and range properly? Yes. The domain is 2 to infinity, right? And the range from -infinity to infinity. And again, you always start from the smaller number, then you look at the big number. Now, what can you observe right here? What can you observe here? Yeah, the values are switched. Like, I mean, of course, right? We switch the XY value. So what do you expect with the domain and range? Well, the domain becomes a new range. The old range becomes a new domain, of course, because you switch the X and Y. So duh, right? That should make common sense. And how do you find the inverse of f of x algebraically? We just did the same thing that we had done earlier. We are going to change the f of x to y. So we say y is equal to x squared plus 2. And then what do? We'll go ahead and swap. We're going to change the x and y, right? And then you will go ahead and solve for y. All right, now we have y squared equals to x minus 2. What do we do to get rid of the square? Square root it, right? So you will square root it. And let me go ahead and show the square root right here. Now, the thing about getting the square root done is that just like what we did earlier with completing a square, it would have to be a plus or minus square roots because we have no idea what the original value was. It could be a positive number or a negative number, so we have to account for both. So we have y equals to plus or minus square root of x minus 2. And to finalize our answer, we'll say the inverse of x is plus or minus, plus or minus okay, plus or minus square root of x minus 2. Now, let me pause a moment right here. And that is, this is the f of f minus 1, the inverse of f, plus or minus square root of x minus 2. Now, we are going to learn more about square roots in the next couple of days. But at this very moment, I want to show you something because we're going to do some graphing of square root functions. So you know how to do 1, 3, 5, 7 with the quadratic, right? Parabola. Well, guess what? The inverse of quadratic function is a square root function. And how do we graph a square root function? Well, we'll do the 1, 3, and 5, but not as we go up. It's as we go to the side, go to the right, okay? So we will see how the 1, 3, 5, 7 would be applied as we go to the right, okay? So this is like 1, 3. So if the next point is going to be graphed, be 5 units away on the x value. So now let's go ahead and address the part C of the question. Is the inverse a function? What do you say? Is the inverse a function? We say no, because what's the proper way to address the justification? Yes. Yeah, you can simply say it fails the vertical line test. Okay, that would be sufficient. Okay, it fails the vertical line test. That would be sufficient right here. You may say, well, every single input has two. Some inputs have two outputs. Some x values have two y values, and that would be a problem. Okay.